Okay, with composite functions, basically the notation is this. You're going to take this negative 2 value, plug it into your f of x. You'll get an output, and then take that output and plug it into your inverse, or whatever function you need. Now, right now we don't know where the inverse function is. So if you watch one of the other videos, or you have any other concerns about inverse functions, you definitely need to let me know, and I can make more videos, or so not. But again, we talked about this switching values. So now I have 3y, I'm going to minus 1 to both sides, minus 1 side, x minus 1. Okay, let's just white this out for a sec. There you go. Divide by 3, divide by 3, divide by 3, or you could just divide everything by 3, whichever one you're most comfortable with. Okay. Okay. So again, this is what our inverse function is. So we take this, we're going to need 2 pieces. So I'm going to do this in colors. I'm going to say, all right, let's start with this piece. Take negative 2, plug it into f of x, which happens to be this. All right, so we have negative 2. That is 3 times negative 2 plus 1, which is negative 6 plus 1, which is negative 5. So here's what happens. We used this into the function, and we got negative 5. Now this negative 5 needs to go into this function. So now we take this and plug it into that. And so what happens is now we have, I'll draw this down a little bit, negative inverse function of negative 5 into x minus 1 over 3. And you can clearly see that negative 5 minus 1 over 3 is equal to negative 6 over 3, which is the same thing as negative 2. So the answer to the whole problem is negative 2, because what we did is we said, all right, our inverse function, our regular function, we started with negative 2, put it into the regular function, took that output, which was negative 5, and then put it into this function, and that's how you get these answers.